What's up, world?
Good morning. My name is Rafik Goubran, and I'm the Vice President, Research, Innovation, and International here at Carleton University in Ottawa. The Carleton campus is located here in a fantastic area. As you can see here, this is the Rideau River. The campus is actually surrounded by the Rideau River on one side and the Rideau Canal on the other side as well. And we're here for the ETSI IQC conference. We're very pleased to have so many people coming from 25 different countries. It's an excellent event here. So Carleton University is a research-intensive, comprehensive university with about 31,000 students. Our research funding last year was approximately $155 million, and we cover a broad range of topics, but we have over 8,000 students in the area of information and communications technology, including physics, electronics, computer science, computer engineering, and others. Okay, so quantum technologies will have a major impact on a broad range of disciplines, ranging from physics, going to electronics, going to computer science, to computing, to math, but more importantly, all of the applications that will be impacted by the quantum revolution. So in my view, well, there are three important points here that I'd like to emphasize. The first one is the speed at which research goes from theory to application. And this would require to have a lot more collaboration with partners, industry partners, with government organizations, with people from the public policy background, and the whole range of people. The need to work in applied quantum is very important. So that's number one. Number two is, given the nature of quantum and the fact that it impacts so many disciplines, it will be important to emphasize the interdisciplinary work where researchers from many fields have to speak to each other, explore new applications, new opportunities, and look not just at the technology, but look at the technology, the application, the implementation, the impact on society, as well as the impact on all of the policies and regulations that exist. So this is the second one. The third one, I would say, is more regarding the talent. So we require now new talent who are able to use the quantum revolution to the best needs of the society. And certainly building that talent in people understanding quantum technology, understanding the impact on quantum technology on their fields will be quite important regardless of the fields that these people are in. Okay. So I'll start by saying that quantum technology with AI and telecommunications is going to create a major revolution in terms of technology in the whole world. So now with quantum technologies, especially on the sensing area, we will have a lot more data generated there from everywhere. Then this data will need to be processed using AI, so quantum will have a major impact on AI as well. But I would add to that as well the telecommunications, because the need to move the data from the sensors to where it's processed on the AI system will be vital. And this is telecommunications at the level of short range communication, long range communications, Wi-Fi, and all sorts of communications there. So I would say that the main underlying principles there are sensing technologies. So quantum is going to create some revolution in terms of sensors, in terms of the size of those sensors, but also the performance of those sensors. So sensors related to motion, sensor related to image, sensor related to everything we can sense. And then I guess the advanced sensing is going to be vital, and we're going to have sensors everywhere. We have now thousands of sensors in everything we know of, and we'll have more of those sensors given the reduction in size and the increase in performance. Now, telecommunications then will help move the information from the sensors to where it is processed on AI. And AI will benefit a lot from quantum as well, because we'll have more powerful computers able to do a lot more things. So with sensors, then telecommunications and AI, the areas of smart infrastructure and the areas of smart health will be impacted significantly. So let me start by the smart infrastructure. So you have now sensors in roads, in cars, and then with the autonomous driving, and with the cars speaking to other cars, cars speaking to the roads, road being instrumented with sensors to be able to measure the traffic and measure everything else. So we'll have a major impact on infrastructure and traffic. Also, we can monitor the status of the road, the status of the bridges, the status of the buildings using embedded sensors there that are benefiting from the quantum revolution. Okay, so in terms of health, quantum will have a major impact on healthcare, whether it will, in my view, have a major cause a major improvement in the healthcare quality that we are providing to people, but also in terms of healthcare delivery systems. So right now we have sensors everywhere with respect to wearable sensors that we wear, whether it is watches with patches and others. We have also sensors that are embedded in the environment that can monitor the vital signs on a regular basis. Ambient sensors in the house, in smart homes, can measure things like quality of sleep, gait analysis, and so on. So when you have all of this information combined with the information from the electronic medical record, and this goes to AI systems that can then look at trends and look at issues, that will help us have early diagnosis of disease, better specialized care for individuals, individualized care. So it will certainly have a major revolution on the way healthcare now is provided and delivered to patients. So in my view, there will be then a major impact by monitoring the health and well-being of individuals on a continuous basis, as opposed to just when they go to the doctor or when they go to the hospital. So if we combine then the sensors that are wearable sensors and injected sensors in the body, patches and so on, with ambient sensors in the home, in beds, sensors in cars, and then the sensors in medical equipment as well, whether it's a blood pressure device. You combine all of this together, it will create a major individualized care for every individual. So the quantum era will create a lot of benefits, as we've talked, whether it is the infrastructure or whether it is healthcare and others, but it will also cause a number of challenges that we have to be aware of. In my view, one of the most important challenges is the cybersecurity challenge. We are relying now more and more on the internet, more and more on our phones, and relying on them on everything, relying on the, like at home, for example, in terms of home security, we're relying more on the internet and sensors that are deployed in the house. In terms of energy monitoring, we're relying on sensors as well and internet connectivity. So with quantum systems and quantum technologies being available, there will be a lot more threat to those systems that we know now. So creating quantum safe networks is vital to the future of quantum. So now the second challenge would be the interdisciplinarity nature of quantum will require policymakers to be aware of the quantum opportunities, but also the quantum challenges. And we need to look more into interdisciplinarity. And unless we can create that interdisciplinarity and make sure that people are aware of quantum, the benefits of quantum, and so on, that will enable us to have the right legislation, the right policies, the right regulations that will enable the deployment of more quantum and the major expansion of what we've started to see now in terms of sensors deployed everywhere, AI being analyzing this data. And I would say another challenge is readiness. We have to be ready to implement those changes. and work closely with industry, government, and various stakeholders in order to implement the new developments and the new innovations related to quantum. Finally, I would say it will have a major impact on talent. So we cannot just assume the status quo in terms of talent development. So everyone should be aware of the quantum era, and not just quantum on its own, but the impact that quantum will cause on telecommunications and AI, and the fact that all of these now will create systems that are far more intelligent than the systems we know right now. So we have to be very careful about that. So in terms of danger or challenges, I would say cybersecurity is number one. Also, with the advances in AI due to quantum and quantum computing, it will be important to rein AI and to understand the challenges related to AI in terms of biases, in terms of hallucination, and other aspects that are impact AI and quantum.
Yeah. What's up, world?